Hi, Namaste. It's Missy and Saudari. Today I am going to talking about the types 1 and type 2 error. Now, these are the my presentation outlines which you are seeing on the screen. Talking about the type 1 error. In statistics, type 1 error is a false positive conclusion, while type 2 error is a false negative conclusion. Making a statistical decision always involves uncertainties, so the risks of making these errors are unavoidable in hypothesis testing. Hypothesis, the probability of making a type 1 error is significance level or alpha, while the probability of the making a type 2 error is a beta. This risk can be minimized through careful planning in our study decision. Now, these are the examples of the type 1 error and type 2 errors which we are seeing in the screen. Now, furthermore, error is statistical decision making, which which are explained here. Using the hypothesis testings, you can make a decision about whether your data of a uh, support or refute your research prediction with null and alternative hypothesis. Hypothesis is a testing starts with the assumption of no difference between groups or no relationship between variables in the population. This is null hypothesis. It's always paired with an alternative hypothesis, which is your research prediction of an actual difference between groups or a true relationship between variables. Now, for null and alternative hypothesis, you test whether a new drug invention can alleviate symptoms of an autoimmune disease. In this case, the null hypothesis is denoted by H naught, is that the new drugs has no effect on symptoms of the disease. Similarly, the alternative hypothesis S1 is that the drugs is effective for alleviating symptoms of the disease. Now, furthermore, you have to look this type 1 error in the screen. Now, talking about the type 1 error rate, the null hypothesis distribution curve below shows the probabilities of obtaining all possible results if the study were repeated with new samples and the null hypothesis were true in the population. At the tail end, the shaded area represent alpha. It's also called a critical region in statistics. If our result fall in the critical region of this curve, they are considered statistically significant and the null hypothesis is rejected. However, this is a false positive conclusion because the null hypothesis is actually true in this case. For example, statistical signification and type 1 error. In our clinical study, we compare the symptoms of patient who received the new drugs intervention or a control treatment using a t-test. We obtain a p-value of 0.035. This p-value is lower than our alpha of 0.05. So our consider our results is statistically significant and rejected the null hypothesis. However, the p-value means that there is a 3.5 chance of our result occurring if the null hypothesis is true. Therefore, there is still a risk of making a type 1 error. To reduce the type 1 error probability, we simplify set a lower signification level, which you can see in the graphical figure. Now, talking about the type 1 error, I have already explained, which again you are showing on the screen. Now, talking about the type 2 error rate, the alternative hypothesis distribution curve below shows the probabilities of obtaining all possible results if the study were repeated with new samples and the alternative hypotheses were true in the population. The type 2 error rate is beta, repeated by the shaded area on the left side. The remaining area under the curve represent statistical power, which is 1 minus beta. Increasing the statistical power of our test directly decreases the risk of the making a type 2 error. Statistical power is determined by size of the effect. Larger effects are more easily detected. Measurement error is systematic and random errors is recorded data reduce power. Sample size. Larger sample reduce sampling errors and increase power. Significance level. Increasing the significance level increase power to indirectly reduce the risk of type 2 error. We can increase the sample size of significance level. Here you can see in the graphically of the type 2 error. Trade-off between type 1 error and type 2 error. The type 1 and type 2 errors rates influence each other. That is because the significance level, the type 1 error rate affects the statistical power, which is inversely related to the type 2 error rate. This means there is an important trade-off between the type 1 and type 2 error. For this, setting a lower significance level decreases a type 1 error risk but increases a type 2 error risk. Increasing the power of test decreases or type 2 error risk but increases it's a type 1 error risk. This trade off is visualized in the graph which are shown in the next slide. It shows two curves. The null hypothesis distribution shows all possible results. We would obtain, if the null hypothesis is true, the correct conclusion for any point on this distribution means not rejecting the null hypothesis. Now, the alternative hypothesis distribution shows all possible results. We obtain, if the alternative hypothesis is true, the correct conclusion for any point on this distribution means rejecting the null hypothesis. Type 1 and type 2 errors occurs where these two distribution overlap. The blue shaded area represent alpha, the type 1 error rate, and the green shaded region represented beta, the type 2 error rate. By setting the type 1 error rate, we indirectly influence the size of the type 2 error rate as well, which you are seeing in this graph. The importance to strike a balance between the risks of making type 1 and type 2 errors. Reducing the alpha always comes at the cost of increasing beta and vice versa. In this graph, the importance to strike a balance between the risks of making type 1 and type 2 errors. Reducing the alpha always comes at the cost of increasing beta and vice versa. With this, I want to depart from this slide. Thank you. Have a good day.